Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over an example problem of how to use molar mass as a conversion factor. So let's get into this. So in this problem we're asked to convert 10.8 grams of carbon dioxide into moles. So we got to use the molar mass because molar mass is a relationship between grams and moles. It tells us the number of grams that are equal to 1 mole of the substance. In this case we're looking at carbon dioxide. So we need the molar mass of carbon dioxide first. So we need to know what the formula is. So the formula for carbon dioxide is CO2. And so now what we can do is we can calculate the molar mass from the periodic table by adding up the atomic masses of the individual atoms in carbon dioxide. And then we get the total, and that total is going to be the molar mass of carbon dioxide, of 1 mole of carbon dioxide. And so if we add that together, we end up getting a molar mass of 44.011 grams, thereabout. And so this is grams per mole. So this is the number of grams for every 1 mole of carbon dioxide. So one of the things I always point out is if you ever have a relationship between two units, or if you have a unit per unit, like grams per mole, you can use that as a conversion factor. Same thing with density. Density is grams per milliliter or grams per centimeter cubed. And so because of that, you can use density as a conversion factor to convert between grams and milliliters, or mass and volume. But in this case, we are interested in converting from grams to moles. So we're going to use the molar mass. So we set up by first taking the 10.0 or 10.8 grams. So we have 10.8 grams of CO2. We're going to put that over 1. And then we're going to multiply by the conversion factor to convert to moles. So this is a one-step problem. So here I have 44.011 grams per 1 mole. I have grams on the bottom, so I want the grams, I have grams on the top, so I want grams on the bottom to cancel out. So I'm going to put the 44.011 grams on the bottom, so 44.011 grams, and this is grams of CO2, and 1 mole of CO2 on top. So now the grams of CO2 cancel out. Now I have moles of CO2 on the top. As soon as I get the moles of the substance that I want on top, I'm done. Now all I need to do is multiply and divide, and I get my answer. So let's go ahead and calculate that out, see what we get. And we have 0. What was it? 0.245, and my calculator gives me 393 moles of carbon dioxide. So then we get our answer, and then once we get our answer, we have to figure out the number of significant figures. Now, how many digits can we keep? Can we keep all of these? Probably not. So when you're trying to figure out number of sig figs, you go back to the rule. Here we multiplied and divided. So the rule when you are multiplying and dividing is that your answer that you get should have the same number of sig figs as the measure with the least number of sig figs. So this one has 1, 2, 3, 4, 5. This one has 5 sig figs. This one has 3 sig figs. So 3 is less than 5. So our answer can only have 3 sig figs. So this 0 is not significant. The 2, the 4, and the 5 are. So we're going to cut it off there. This 3 is it's less than 3. This number is less than 5. So that means we don't need to round the 5. So that's going to be 0.245 moles of CO2 would be my final answer. And that, ladies and gentlemen, is how you use molar mass as a conversion factor. I hope this video is helpful. I hope you enjoyed and learned from this video. If you did, then please like the video, hit that like button, share the video with your friends, subscribe to my channel, hit that notification bell. When you do, make sure that you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have any suggestions for any future videos, I would love to hear them. Thanks for joining me and have a great day.